I have a busy day as well today. I feel like I've been going since 7 a.m. and I won't end until like 4:35 p.m. So I feel your pain there. Busy, busy day. That's how I feel, Rebecca, right? All right. So totally didn't even realize I sent an email yesterday afternoon with a video explaining my major fudge from class on Tuesday. Or maybe I sent that Tuesday afternoon. I can't remember exactly when I sent it. But anyway, I didn't actually realize until I started grading some assignments that I made a mistake with the values for A and B with that semi major and semi minor access. I didn't even realize that that semi term was in there, and semi means half, right? So when you hear semicircle, you think of half a circle. Same thing happening here with the semi major axis. It's really technically only half the length of the major axis. Same thing with that semi minor. It's only half the length of the minor axis. So I thought today we could start off by looking at one of the questions from 8.02 where it dealt with the axes. So we'll walk through this one just to get us started here, and then we'll move into our hyperbolas for today, which is our last conic section we're going to be looking at. All right, so question 2 was asking or telling us to find an equation in standard form for an ellipse that satisfies these given conditions, where the major axis has endpoints at plus or minus 5, 0, and the minor axis has a length of 4. All right, we need to identify which column we're going to go ahead and use to create our equation. Should I use column 1 or column 2, looking at the information that is given to me? Can anybody tell me which one we're going to use? The first. Yeah, how did we know it's going to be column 1? Yeah, the plus or minus 5 in that first one, exactly. So when we take a look at that, that signals that it is going horizontally, right? So a horizontal line is going to be your y equals something. So your focal axis is going to be a horizontal line. So that's signaling y equals k there. So we are going to go ahead and use column 1. And I like that you notice that it's the x value that is changing, right? And if you notice in that column, it's the x values of the foci and the vertices that are changing as well. So a really good indicator there. All right, what is the center of this ellipse? So can we pull out what the center is going to be? Yeah, it's going to be the exact middle of the axes, right? So if you think about where that major and the minor axis is going to intersect, it's going to be right in the middle of the major axis. So right in the middle of the major axis is 0, 0. So this one is centered at the origin. Okay, so we're going to let h equal 0 and k equal 0. Okay, we need to find the values for A and B, so we're going to start with those axes then. So the major axis is how long? So all together, how long is that major axis? It's 10. So if the major axis has a length of 10, what is the value for A going to be? Half of that, which is 5. Yep, so half of that is 5. What is the length of your minor axis? 4. So what's the value for B? which is your semi-minor. Yeah, half of that is 2. Good, so now I think we have everything we need. We just have to substitute it into our formula. So x minus h, which is 0, so that's just an x squared, over a squared. Now 5 squared is 25. I saw a couple people putting 10 there. Don't forget that you're going to square it, which means 5 times 5. Okay. And then in the second piece, y minus 0 is just y. And then b squared, you did turn out lucky here if you made that same mistake, because 2 squared is the same as 2 times 2, which is your 4. Good. So again, I didn't steer you completely wrong with everything. It's just that we need to make sure when we're pulling the values for a and b, if we're looking at the axis length, that we slice it in half. Right? So we got to divide the major and the minor axis by 2 and use those values for a and b. Okay, so just some minor tweaks, and we want to make sure that moving forward, we're doing that anytime we're dealing with our ellipses or circles. All right, other than that, I didn't really see any other major mistakes. There was some good simplifying. So on the last one, when it asked about eccentricity, if your answer didn't match up completely with the answer key, it's because you simplified more. So I saw some really good simplifying occurring with that last question with eccentricity as well. Any other questions regarding that 8.02 lesson at all? Okay, if it pops back into your head, just let me know, Rebecca, or you can always email it to me as well. No big deal there. I hate when that happens, though. You're like, I know it, and then it's gone. Happens to me all the time. All right, the last conic section we're going to take a look at today is our hyperbola. Again, a lot of the same terms are being used here with your hyperbola that we've seen with our other conic sections. So again, we have foci. Notice that the focus is inside each part of our hyperbolas this time. The vertex, we have 2 vertices because we've got technically kind of 2 mirrored parabolas occurring. So there is 2 high points or low points there. And the center is the part that's right between the 2 vertices and right between the 2 foci as well. So that center really means the middle of anything that you're looking at. The focal axis is what connects your vertices and the foci. Right? So that focal axis can technically be horizontal, or if you flip it around and your hyperbolas are opening up and down instead of left and right, your focal axis, oopsie daisy, is going to be vertical. Okay, so we can have it either way there, and I will have some pictures coming up in a moment regarding that. Notice that the value for A, because we will have A and B and C again appearing in our formulas, that the A values are going to be vertical lines through the vertices there. Okay. Essentially what's going to happen is we're going to have something called a transverse and a conjugate axis, and that's going to create sort of a box in the middle here, and that box will then show us the asymptotes, because believe it or not, there are some asymptotes that appear in these hyperbolas, and they actually will make an X, and that X will happen right through the center of our hyperbolas there. I know there's a lot going on here, so let me move forward to the next slide here so we can kind of see the big picture. Here's that box I was talking about, and here is the chart that we're going to be using. Now again, there are 2 charts. You have one chart that's centered at the origin, 0, 0, and you have another chart that will be centered at h, k. I would probably use the h, k chart if you're going to write something down in your notes, because that will generalize every possibility. Now notice again, what is the difference between the standard equation here and the standard equation that we had with our ellipses and circles? They look very, very similar, but there's one slight difference. What's the difference? Yeah, in the middle, you have a minus sign now instead of a plus sign. With your ellipses or circles, that was a plus sign, but now you have a minus sign, and that changes the shape of your graph drastically. All right, you still have a focal axis, so here you can see the focal axis will be this one for column 1, and the focal axis is this part for column 2. You have your foci, which are located at plus or minus C. Again, that would be inside your hyperbola pieces there. The vertices are plus or minus A. The semi-transverse axis, and we're not going to fall for the same mistake twice. Notice it does say semi-transverse axis, so if they give you the length of the transverse axis, we know we have to divide that by 2 to find the value for A. And same thing with that conjugate axis. If they give us the total length of the conjugate axis, we have to divide that by 2 to find the value of B. Now, you can't actually see it drawn into the 2 examples over here, but I did pull a third picture to actually highlight what that conjugate axis is and what the transverse axis is. And these two can flip around depending on which direction that opens, right? So if you have your hyperbolas going from the top and bottom, the red and the blue pieces would switch. It looks like a box in here. Sometimes it'll form a rectangle. Sometimes it might be a perfect square. But if we were to connect the corners of this box that's created from the conjugate and the transverse axes, we could then find our asymptotes of the graph. And the asymptotes are happening at plus or minus B over A or A over B times X. So depending on which column you're looking at is going to be those equations for the asymptotes. Okay, lots going on. Any questions with like the formulas or what each piece is kind of referring to in our chart? Yeah, if they aren't related to math, I'm not quite sure how much I could help you out with those thousands of questions. All right, we will be talking about eccentricity in a few slides as well, because there is eccentricity with our conic section, so we'll look at that a little bit more in depth and what that eccentricity is actually referring to. So we'll have that coming up in a little bit. All right, let's go ahead and take a look at an example here though. It says find the vertices and the foci of the hyperbola. So just like we were given with our ellipses, what do we need to do here to change that equation to look like the ones in the chart? Yeah, remember we want it to equal 1 at the end. So just like with our ellipses in the last section, we're going to go ahead and start by dividing everything by 36. Okay, we will simplify then. From there, this seems to be a really common, it feels like it's a really common values. They seem to use 9, 4, and 36 a lot. Okay, now we have to decide which column from our chart should we focus on so we can start pulling information. So what do you guys think? Column 1 or column 2? Yeah, how did you know column 1? You're correct. How do we know? We're getting a lot better, by the way, at deciphering which column to use. Yeah, a is a larger number and it's under your x squared. Perfect. All right, let's go ahead and pull what we need. So it says to find the vertices and the foci of our hyperbola. So we're going to need C and A. In order to find C, we're going to need B because we're going to have to use the Pythagorean relation from below. So let's just start with the values for A and B. What are the values for A and B? 3 and 2, respectively. Very good. That's what I was going to say. You can tell them respectively. Yeah, so 3 and 2 respectively there. All right, so we can go ahead and find C as well using the Pythagorean relation. So C squared equals A squared plus B squared. This is the nicest Pythagorean relation because we just have to take these and add them together and then take the square root. So 9 plus 4 is 13. Yep, so we're looking at the square root of 13 there. Woohoo! Yeah, so I really like that Pythagorean relation for our hyperbolas. We can find it pretty quickly just by adding that a squared and b squared together. All right, let's go ahead and finish off what we're looking for then. The vertices right here, what are going to be my two vertices for this hyperbola? Yep, we do have two distinct points, plus or minus 3, comma 0, which is going to be your 3, 0, negative 3, 0, as Isaiah's put that. All right, the foci is next. What are the foci of the hyperbola? Plus or minus the square root of 13, comma 0. And again, there are two distinct points there, the positive value of square root 13, comma 0, and the negative value of square root 13, comma 0. Good. All right, the center is obviously at the origin, 0, 0 here, because we don't have any subtraction or addition going on with the x and y in the numerator piece. Good. Any questions with the first one? So again, pretty basic as long as we have those charts there to pull from. We just got to follow along with those. All right, let's create an equation now. We know that the hyperbola has foci of 0, negative 3, 0, positive 3, and the conjugate axis has a length of 4. All right, it does say to sketch the hyperbola, but at any point in time, if you need to graph, you can use GeoGebra to assist you. All right, so if you do need to graph or sketch something, you can go ahead and use GeoGebra to assist you, but you'll obviously want to make sure that that graph matches up with the information you have. So is that conjugate axis have a length of 4? Do the foci look like they'd be at 0 plus or minus 3? All right, so before we begin, let's identify which column we're going to look at to write our equation. This time the second column, it looks like Tommy says. Does everybody agree? Column 2? Yep, because the y value is changing. Woohoo, nice job, Rachel. Yeah, so when we take a look at the foci, it's that y value that changes. So in our chart, we want that second column because that's what the y value is there. What is C according to our information? Because we can pull that value pretty quickly. That's 3. And what other value do I know? So given all the information here, which other value can I find? We can find B, yeah, and we know that B is that conjugate axis or the semi-conjugate axis. So we have to take that conjugate axis and divide by 2 to get 2. So 4 divided by 2 is 2. Now we have to use our Pythagorean relation to find A. And once we have A, we can then go ahead and write our equation. All right, let's see if we can find our A. So if I go ahead and plug in what I know into the Pythagorean relation, we'd have to work backwards a little bit. And what do we get there? Square root 5, right? Because 9 minus 4 is 5, and then we have to take the square root of that. Awesome. Where is h and where is k? Yeah, and how do we technically know that besides that's the only chart we have to go off of at this point so far? You can tell by the foci, right? The center of the foci. Yeah, so if you're looking at the 0, -3, 0, 3, the center is going to be right in the middle of those two foci. So right in the middle of 0, -3, 0, +3 is 0, 0. Beautiful. All right, we got everything we need. We're going to go ahead and write our equation. So we'll have a y squared over, it looks like 5 this time, right? Because a squared, square root of 5 squared is just 5, minus x squared over 4 equals 1. All right, questions with that equation? Now, it did say to find the equation and then sketch it. It also said to sketch its asymptotes. Let's just find those asymptotes real quick. So if you were to look at the graph or try to sketch one on your own, you could draw those kind of invisible lines in so you know where your hyperbola is approaching but not crossing over. So you'll have two asymptotes. They're occurring at y equals plus or minus a. So square root 5 over b times x. So technically you will have two lines. You will have the square root of 5 halves x, and y equals the negative square root 5 halves x. So that's where your x, so to speak, will be for those asymptotes. All right, here's that chart that you'll probably want to copy down now. So here is the chart where your center is at h comma k instead of at 0, 0. Notice the foci and the vertices do change a little bit, as well as your asymptotes there. They do take into consideration the h and the k aspect instead of just having 0, 0. All right, I'm going to go to the next slide because you guys know me. These charts are going to appear on every slide from here on out. So if you're working on copying that, obviously it's in your book, it's in the online lesson, and I'll have it on every slide under our example. So if you're still working on copying that, take your time. Just leave some space in your notes there, and we can constantly be looking back at that. All right, let's go ahead and see if we can answer this question. Find the standard form of the equation for the hyperbola whose transverse axis has endpoints at -2, -1, 8, -1, and whose conjugate axis has a length of 8. All right, we got to identify, first of all, maybe we can identify how long the transverse axis is. And also, we can maybe identify which column to be looking at once we identify that. So let's find the length of the transverse axes. What is the length from -2, -1 to 8, -1? That's 10. It's a length of 10. All right. Where is the center of this? So if that has a length of 10, that means the center is exactly 5 spaces from either one. So what is the center point going to be? Yeah, so 5 spaces from either one. You'd have to add 5 to the -2 or subtract 5 from the 8. Either way you look at it, it puts you at 3, -1. All right, is this transverse axis horizontal or vertical? Let's identify that next. It's horizontal, right? So if your y value is staying stable. It's horizontal. Which column should I focus on when I want to write my equation now? The first or the second if the transverse axis is horizontal? The first, right? It's that y value that's not changing. So when we look at that foci and vertices, we want that y coordinate to stay the same. And that's where that's occurring at. All right, so I know H is 3. I know K was -1 because that's coming from the center of that transverse axis. I can now find A. If the transverse axis had a length of 10, what will A be? Yep, half of that, which is 5. And we can also find B because we have our conjugate axis with the length of 8. So that means B is 4. Awesome. I think we have everything we need to get the equation then, right? We have H, K, A, and B. Yep, we got everything we need. So I'm going to go ahead and start this equation out. X minus 3 squared over A squared, which is 25, because 5 squared is 25. Y minus K, so that's going to actually turn into a Y plus 1 squared over B squared equals 1. All right, nice job, guys. Any questions with our first example of using that chart where the center is at H comma K instead of 0, 0? Yep, so it helps, I think, to kind of, if you can't see it algebraically, to kind of visualize what's going on. So for me, I think it might help to actually graph those points. So like -2, -1 is right here. And then 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 to -1 is over here. So if this is the length of that transverse axis, we can then count the actual spaces between there, right? So in other words, you could just subtract those x values of 8 minus -2. 8 minus -2 would be an 8 plus 2 to get that length of 10. Yeah, so if we can't kind of mentally see what's going on, I would suggest maybe drawing it out and having that visual aspect, because that kind of helps solidify your thinking there. And it also helps you identify that that transverse axis is in fact horizontal, right? You can physically see what's happening. And then the conjugate axis would be right through the middle of this transverse axis. So right in the middle is this 3, -1 point right here, right? There's the exact middle. It splits that transverse axis into 2 equal parts. Now this would have a length of 4 on the top and 4 on the bottom. Obviously I didn't count those out accurately, but that's where that conjugate axis would appear in the graph. And when you graph this in GeoGebra, you will not physically see the transverse and the conjugate axis, right? That's not technically what's being graphed. What's being graphed is the hyperbola this way and the other one coming this way. Mine's slightly off, sorry about that. But that's what's being graphed. So a lot of those pieces of information are kind of like invisible lines that are occurring. All right, any other questions with this one? Okay. Let me just move forward because I'm taking a look at our time here. I do want to talk about eccentricity quick of our hyperbola. So I grabbed an extra piece of information from online about what eccentricity is. I think it helps describe it a little bit better. So when we hear that term eccentricity, which is shown as the letter E, right? We've noticed that back with our circles and our parabolas a little bit as well. We have E there. It shows how uncurvy. I like that. I like that term, uncurvy. The hyperbola is. So, if we read the little stuff up here, your C is greater. If the eccentricity is greater than 1, we know we have a hyperbola occurring. If the eccentricity is between 0 and 1, then we know we have an ellipse occurring. So this value for E tells us how close to a circle we're getting. If the eccentricity equals 0, we know that we have an actual circle occurring. If it's between 0 to 1, that means it's starting to get stretched out, right? So your complete circle, which had eccentricity of 0, is now getting stretched out. So that eccentricity, as it gets greater, you're elongating kind of that circle piece. And as we keep getting bigger and bigger and bigger, it's spreading out that circular shape, right? You're getting closer and closer to a line. So instead of having it curved completely, it's widening, widening, widening. If you have an eccentricity of 1, that means you have your parabola shape occurring. And then larger than 1, you should have your hyperbola starting to occur, right? Those are getting stretched out more and more. So that's what that eccentricity is technically focusing on there. All right, notice that they're using, I would probably use this formula to help you find the eccentricity of your hyperbolas. So that square root of a squared plus b squared all over a. And again, this is C. This is coming from that Pythagorean relation that we had in our chart. Any questions with the eccentricity there? So hopefully that kind of goes into a more descriptive realm of things, I guess, when we're talking about that eccentricity. Because I don't feel like the book did a very good job of actually explaining what eccentricity was. So hopefully that gives you a better picture of what's occurring and what it's referring to. Okay, let's go ahead and see if we can dive into some of these more complex setups. Let's take a look at this one. This is a fun one. It says find the coordinates for the foci and vertices for the hyperbola given in the equation below, and then find the equations of its asymptotes as well. All right, what are we going to do? Because that equation does not look like any of the things in standard form. We have to complete the square. Yeah. So I noticed that the y's are kind of grouped together, and I noticed the x are kind of grouped together already. So I'm just going to move that constant to the other side. So we'll move this 4 to the other side by adding it, right? And then we will work on completing the square. Well, when I group the y's together, in order to complete the square, what has to be done first? So before we can start with completing this square process, what do we have to do? We have to take out the GCF of 16, right? Because we need that y squared to have a 1 as its coefficient. Okay, if I take out the 16, that's going to leave a y squared minus 2y there. Okay, and right now I got the 4 on the other side. Let's go ahead and complete the square here. So we take half of the middle term. What's half of negative 2? Negative 1, and we square it, hence completing the square. So negative 1 squared is a positive 1. If I add 1 inside parentheses, to keep it balanced, what should I add to the other side? Yay! Yeah, so we saw that on Tuesday's class, right? We're not going to fall for missing the GCF again here. So we're going to add 16. All right, let's do the same thing for the x's now. And before I get too far, I'm going to go ahead and just make sure we factor that. When you factor it after you've completed the square, remember it always factors to y and then whatever half your middle term was. In this case, it was -1. All right, what do we need to take out for the GCF of my x's? We have to take out a -1. Yep. That would leave an x squared minus 4x there. All right, let's complete the square. What's half of -4? -2. What's -2 squared? A +4. If I'm adding 4 here, what should I add to the other side? A -4. Woohoo! All right, so let me see now how this is going to factor. X, whatever half my middle term was, squared. And what do we have on the other side of my equal sign now? So if I got a 4 plus 16 minus 4, yep, that'll be a 16. We're super close. What's the last step to getting this into that standard equation? Divide everything by 16. So let's see what that leaves us with then. Looks like a y minus 1 squared all over 1 minus x minus 2 squared all over 16 equals 16. Why isn't it 12? Where over here? Oopsie, thank you. Thanks, Rebecca. Are you talking about why isn't it equal to 12, Isaias? Because remember we added that constant of 4 over first. So instead of having that 16 minus 4, yeah, there's that plus 4 from moving the constant as well. Nope, that's okay. Mine does that all the time. Tuesday was living proof that my brain malfunctioned, so it happens to the best of us. All right, which column should I focus on when we're taking a look at up here? Generally, I would say, yeah, probably column 1, but I actually think our B, let's see, is that because of where the X is located in there, I'm wondering if we should actually focus on column 2 instead, right? So I'm thinking we have to probably focus on column 2 because of where the X is placed. If it was a plus sign, I for sure would say column 1 because we can swap the two terms without any worries. But because there's a minus sign in there, I actually think our value for B is going to be larger than our value for A this time. So it seems a little bit backwards set up. But we'll go ahead and use column 2 to pull our information. Let's start with the center. That one is going to be easy to find. What's the center of this hyperbola? Yep. Although it didn't ask us to find that center, I still think it's important to label that. Let's start with the foci next. And maybe we have to actually find our value for C before we can do that. What will A equal and what will B equal, respectively, looking at our chart and our equation? One and 4, yeah, which is a little bit backwards than what we're used to thinking, because generally we're used to thinking that A value should be larger. But we'll roll with it. It's a little bit iffy here. Using the Pythagorean relation, let's see what we can get for C. What will C equal? I think it's going to be a little bit larger than that. Remember, you have to square each one, so it'll be 1 plus 16 instead of 1 plus 5. There you go. I think square root 17 is a better value for our C. So that means our foci is going to be at H, which is our 2, and on our K, which is 1, plus or minus the square root of 17. All right, let's figure out where the vertices are going to come into play. Let's see, that's going to be our H, comma K, plus or minus A. So at what two distinct points are the vertices going to be at? Two, 0. I see lots of people type in, so I'll wait for them to come through. Awesome. And besides the foci and vertices, they want the equations for the asymptotes as well. So let's see, we got y equals plus or minus a over b. And I'm sure Isaias is probably typing this out for me as well. Possibly. All right. Oopsie. We'll use a square instead of a circle for that. All right, questions. I see Isaias is still typing, so we'll see what he pops up there. Oh, I thought it was going to be our equations. Nice job. Questions with that one? There's one extra thing I want to talk about today that I don't believe was mentioned in the book, but I have this from a previous pre-calculus book that I used way back in the day, and I thought it would be helpful for you guys to share it here as well. We can classify our conics if they give us in this general equation of this form ax squared plus cy squared plus dx plus e plus f. So instead of having to complete the square and try to put it into one of the formats that we're used to seeing for either parabola, ellipse, or hyperbola, we can easily use the rules below to help us identify what type of conic section we're actually looking at without having to complete the square. All right, so first of all, we have to realize that the a value that they're talking about is the coefficient in front of the x squared, and the c value that they're referring to is the coefficient in front of the y squared. All right, so if the a and the c values are equal to each other, we know we have a circle occurring. Now, the other ones, when we multiply a and c together, if they equal 0, we have a parabola happening. And that's because one of your terms does not have an x squared or a y squared, right? Generally, the parabola is the easiest one to identify because only one of the terms is squared. And you don't have a squared for the other variable. If you multiply a and c together and it's greater than 0, then you have an ellipse occurring. If it's less than 0, then we know we have a hyperbola. So let's go ahead and classify each equation below as either a circle, parabola, ellipse, or hyperbola. So what is our value for a in this first example? Careful, we want, I guess it technically wouldn't matter, but a is the one that's in front of the x squared. So what value is in front of the x squared? Yeah, technically a -4. And then what 25 would be our value for c. Now, would it necessarily matter if they were swapped? No, because you still should be able to identify whether a circle, parabola, or ellipse, or hyperbola is occurring, because either a and c will be equal to each other for your circle, or you're going to multiply the two numbers together anyways and see how that relates. Obviously, A and C are not equal to each other, so we do not have a circle happening. We're going to go ahead and multiply those. What is A times C? Negative 100. And how does that relate to 0? Is that equal to, greater than, or less than? Yeah, that's less than, obviously. So what type of conic section do we have in this first equation? This is a hyperbola. Okay, that was a lot faster than having to try to go through and complete the square with everything. Now, if they asked us for specific details, like what the center or what the vertices or the foci were, then we would have to go through that process of completing the square to identify all of that. But if they just want the type of conic section, this is a lot faster. All right, let's take a look at the second equation. What's the value for A and what's the value for C? Nine and 4. Obviously, 9 and 4 are not equal to each other, so we'll multiply them together. What is 9 times 4? How does 36 relate to 0? So what type of conic section do we have? We got an ellipse happening. All right, last one. What are the values for A and C? Three and question mark. Is there a y squared? If there's no y squared, what value do you think it will obtain? A 0. Yeah. And obviously, if you only have one squared term, this should be a dead giveaway. What type of conic section do you have? A parabola. So technically, you probably don't even need to do the multiplication there. But if you were to, 3 times 0 is 0. 0 equals 0. You know you have a parabola occurring. Awesome. Any questions with being able to identify the type of conic section you are dealing with just by looking at your general equation here without having to complete the square? All right, I think we'll wrap up there. Obviously, I had more examples we could go through, but they were just kind of your general, generic examples that you guys can handle by looking at your chart. All right, so go ahead, give 8.03 a go. You should be able to do that one without any issues now. If you do have any questions, obviously bring them with you next week to class on Tuesday. All right, that's all I got for you today. Have a great rest of your week, and I'll see you guys all on Tuesday again. Bye, everyone.